All right, guys, in this video, we're going to be looking at some reaction rate and a rate law question. We got a short answer and a multiple choice. So in this one, we're going to be looking at reaction rate. The question says, a student performs an investigation to study factors that affect the rate of a reaction. In each trial, the student combines 50 milliliters of hydrochloric acid at 21.2 degrees Celsius with 1 gram of calcium carbonate. And measures the time required for each reaction to go to completion. The data are given in the following table. So looking at this data, we've got concentration of hydrochloric acid, we've got the particle size of calcium carbonate, and we've got the time of reaction, so the time it takes for the reaction to complete. The question says, the student correctly identifies that trial 5 is inconsistent with the other trials. Explain why the student's claim is correct using the data in the table. So apparently number 5 is incorrect compared to the rest of the data. And at first glances, it doesn't look like that because we've got 3 molar hydrochloric acid, we're using small chunks, and the time to completion is 2:27. So there must be something wrong with this time to completion compared to the others. And there are 2 possible answers in this one. So one, we should see that, especially in these first 3 trials, by going from a fine powder from small chunks to large chunks, it progressively takes longer time to complete, and that makes sense. We're decreasing the surface area in this case by making them chunks. Remember, powders are going to be our fastest reaction, so they'll have the shortest time to completion, and large chunks should have a really long time for the reaction to occur because it can only attack so much surface area in a large chunk. But we have something wrong with our next 3 trials going from fine powder to small chunks to large chunks. Notice there's a big increase in the small chunks compared to the large chunks. So this is inconsistent. So you could talk about how these small chunks should have a shorter time reaction than the large chunks do. But it should also fall between the fine powder and the large chunks. So the fact it takes 227 seconds is not realistic data for this experiment, comparing it with the powder versus chunks version. The other option you could use is the molarity. Notice in the first 3 trials, they used a 1 molar concentration of hydrochloric acid, whereas 4, 5, 6 used 3 molar. And the time it took for the 1 molar was significantly less than the 3 molar. It should actually be much less because we have a higher concentration of the hydrochloric acid. So this is an inaccuracy here that you could use as an explanation. So these are the 2 that you could have used as your explanation. Make sure you explain the comparison of each one and why this number is too large for both scenarios. You could have used hydrochloric acid, or you could have used the particle size as an explanation. You don't have to do both. You would have just have to done one on this one because it just says I don't think it doesn't say you have to explain all reasons, so you just have to do at least one as an explanation. Okay. All right, this one's going to be a rate law question. And there's a couple ways they could give you a rate law question. The one I think that will happen the most is they will give you a data of information, and you'll have to pull that data to understand what the rate law should be. So this question says the initial rate data in the table above were obtained from the reaction below. What is the experimental rate law for this reaction? Okay, you have to use this data to identify the rate order or the reactant order for each reactant. So NO and O2, and we're going to try and write a rate law. Okay, the way you do that is first you got to look at your data. You got to find 2 experiments or 2 trials where one of the reactants will change while the other reactant stays the same. So looking at experiments 1 and 2, the concentration of NO doubles, but the concentration of O2 stays exactly the same. So this is a perfect data we can use to figure out the change in NO, or nitrous oxide. So nitric oxide, my bad. The initial rate was 2.5 and it went up to 5.0. So as the NO concentration doubled, the rate of the NO also doubled. So if they both double, they're corresponding to the same change. That would mean it's first order. Okay. Looking again at the data, we need to figure out where does O2 change, but NO stay the same. And that would be with experiments 2 and 3. Here it stays the same, but here the concentration quadruples. It goes 4 times as big. So as the concentration of O2 double or quadruples 4 times as big, what happens to the rate? Okay, this goes from a 5.0 times 10 to the negative fourth and 8.0 times 10 to the negative 3. Now, if you can't do that math in your head, use a calculator. All you got to do is take the final rate and divide it by the initial rate to figure out that change in difference. In this case, it gets 16 times as large. The rate gets significantly faster, which means that the change is being squared. So it is a second order reactant, okay? And if it's a second order reactant, then we got to make sure it is included in the rate law as such. So this rate law, without even looking at the answer choices, we're going to be looking for something that has rate equals K, concentration of NO, and since it's first order, it will just have a 1 as the exponent, but if it's a 1, then we don't really need to include it because anything to the 1th or the first power is just itself. And then we need to include O2 to the second power because it is a second order reactant. So we're looking for an answer choice that fits that, and that would be B. B is the correct answer choice. Okay, A is not right because it's saying they're both first order. C is not right because it's saying NO is second order and O2 is first order. They got it backwards. And this one's not right because they're saying both of them are second order and they are not. Okay, NO is just a first order reactant. Okay, so B is the right answer. Hopefully that was helpful.